All right, and we're back with numbers 6 through 10. So let's go through these. All right, number 6. And it's, again, the same standard. So it's read question, find the key terms. I'm going to write it down here. Question, and you find the key terms. Okay, then you answer choices, match the key terms. Eliminate 2 answers. And then find your proof in the pudding. Just kidding. Find your proof in the passage. I almost wrote pudding on this. Whoops-a-doodle. Okay. So, does the information given in the passage support, that's agree with, the hypothesis that solubility of compounds that absorb heat reactions increases with temperature? So, does the solubility for ones where they absorb heat? So, yes, because this increases temperature increase. Yes, because these ones. All right, so we can't actually do step 3 here because we need to look at 2 things. So, first, we're going to find half of the proof in the pudding. So, which ones here absorb heat? And that means that it's absorbing heat with a positive enthalpy. So, these 2. That means NaCl and KNO3 absorb heat. So that means NaCl and KNO3 are our key terms. Now we can go cross this off. Or now we can go look. So we need these 2 reactions to have a solubility that increases with temperature if that's going to be supported. So this one, as you increase the temperature, that one decreases, and that has a negative. So we can say that CaSO4, the solubility of CaSO4 did not increase. So we can cross off answer choice B. Now, let's see here. So, NaCl increases with temperature. KNO3 increases with temperature. So yes, the solubility of these 2 compounds increase with temperature. So, the answer choice is A. So that one was a little trickier because you had to combine 2 things. All right, number 7. Based on the information in the passage, is the conclusion that compounds composed of 2 elements are less soluble than compounds composed of 3 elements? So we only have 1. That means NaCl, KNO3, and CaSO4. So first off, if I've looked at this graph as much as you have, we know that NaCl has a compound max of 40. That one is a max of 250 at 100. And at 100, this one goes down to like, well, that one's really low because the maximum on that one is 0.17. So, right here are less soluble than compounds composed of 3. So, NaCl, we need to talk about NaCl in this answer choice. So if it doesn't talk about NaCl, then we can cross it off. So C and A, because that it has to talk about one with 2 elements. It can't compare ones with 3 and 3. So yes, because NaCl was less soluble than KNO3, and no, because CaSO4 was less soluble than NaCl. So 1, we know that CaSO4 was less soluble. So that's going to make our answer choice D. Okay. Based on the information provided in the passage, is it reasonable to conclude that compounds with higher enthalpy dissolve faster than compounds with lower enthalpy? If you look at the table, KNO3 has the highest enthalpy. The SOL just means of solution. So KNO3 has the highest enthalpy with 34. And does it dissolve faster? So, now, let's look at what we have compared. Temperature, solubility. Do we talk about speed at all? Do we have a rate? No. So, I don't know the answer to that because we don't have a rate. So, we're going to say the answer choice is D. Because no passage has the key term of faster, speed, rate, etc. None of that matches. The only thing here like that key term doesn't match the question, that key term doesn't match the question. It says solubility, but it doesn't say faster. That says enthalpy, but it doesn't say faster. Would it be reasonable to conclude that compounds containing oxygen are more soluble than compounds not containing oxygen? So again, that's KNO3, which if we look above is 250. NaCl is 40. CaSO4 is 0.17. This has an oxygen, but it has the lowest solubility. So we're going to say no, because the solubility of NaCl was always greater. And if we did our step 2, or step 3, eliminate the answer choices, we would eliminate B and D, because they talk about oxidation, and that has nothing to do with this. So, this one, if you answered number 7 correctly, you could use that same information from number 9. And the last question for here. From the information in figure 1, that's where we will be looking later, is it reasonable to predict that exposing a biological soil crust to foot and vehicle disturbances would increase its FTV? So, undisturbed, is this figure 1? Yes, so I'm going to go to figure 1. Okay, first off, yes, the crust FTVs increase, decrease, increase, decrease. So we can't do step 3 here because they all have the key terms. So now we're just going to look at the graph. When we expose it to foot and vehicle, across the board, what happens to the FTV here? So the FTV, these are downward facing arrows. That's a decrease. So we're going to say no. So I'm going to cross off A and B for 10. Now let's look at our reasons. No, the FTV increased. No, the FTV decreased. So what did they do? They decreased. The answer to 10 is D.